Measures of central tendency. Our objective: determine the arithmetic mean, the median, and the mode of a variable from raw data. This probably takes you back to, I don't know, perhaps grade 4 or 5. I'm not exactly sure when mean, median, and mode started. Maybe grade 6, but I'm sure you've seen this from long ago in your education history. We're going to have to kind of define it here and show how StatCrunch can find it for us. So let's first define what measures of central tendency are. They are any of several methods used to find a typical, also called central, also called average, data value. So we're summarizing the data with one data value, okay? The most common are mean, median, and mode. All right, so this table tells us a little bit about each of them. The mean, how do you calculate it? We add them all up, add up all the observations, and divide by the sum of the observations. That's down here below, which I'll show you that now. No, I'll come back and show you that. The interpretation, and this is a question that will stump many people. What is the mean? The mean is the one number. All of the numbers, and I forgot the S here, all of the numbers would be if they were all the same. So if you have 5 test scores and someone says find the mean, well, you add them up, you divide by 5, and you come up with a mean of, let's say, 85. What that means is that if all of my test scores were the same, they would all be 85. Okay, of course, normally your test scores probably will all be different, but that's what the mean is. When do you use? When the data are quantitative, we're talking about numerical data here, and the frequency distribution is roughly symmetrical. We talked about that in a previous video. You have a roughly symmetrical bell-shaped frequency distribution or distribution of the data. Okay? The median. How do we calculate the median? Arrange the data in order, either from lowest to greatest or greatest to lowest, and determine the value of the observation that is in the middle. Median is basically the middle point. Okay? Interpret this. What does the median do? The median simply divides the bottom 50% from the top 50%. Okay, when is the median used? Well, again, the data are numerical. The data are quantitative. And in this case, we use the median. It's a better measure when the distribution is skewed to the left or to the right. Okay, so we have a symmetrical distribution. The mean is what we tend to want to use. We have a distribution that is not symmetrical, skewed left or right. The median is going to be a better one number representation of the data. The mode is the most frequent observation. That's the interpretation and how you compute it. Just add up the one or more than one that appear more than others. You might have no mode. You could have no mode, you could have one mode, you could have multiple modes, okay? When do we use this? Well, certainly when the data are qualitative, when the data are categories. Favorite ice cream flavors. Well, that has nothing to do with numbers, so we can't calculate a mean or a median for favorite ice cream flavors, but we can certainly calculate a mode. It looks like most people chose chocolate, for example, okay? Or the most frequent observation is the desired measure when you're talking about numerical data. Really, it's much more used with qualitative data is the mode. Mean and median are what you tend to, is primarily where we go when we're talking about numerical data. Okay, I spoke to this earlier. How do you calculate the mean? What does that look like mathematically? Here's what you do. And I will introduce some notation. If we're dealing with a population, okay, we're going to indicate the mean with this symbol, this Greek letter mu, okay? So a population, we have parameters, and we're going to use mu. Greek letters are usually used to represent parameters, and of course parameters P goes with population P. And here's how you calculate the mean. You add up all the data values, you divide by the total number of data values, and in mathematical notation, the sum of all the data values divided by the number of data values is what this is. We're talking about a sample. We want to find the mean of the sample, and we indicate the mean with X bar, okay? We use Roman letters, X, Y, Z, etc. when we're talking about statistics. And of course, statistics go with sample data, SS. And so we use mu to indicate a population mean. We use X bar to indicate a sample mean. And it's the same thing. Add up all the data points, divide by the number of data in the sample, which is small n, lowercase n, as opposed to population uppercase. And here's the same thing in a shorter form with the summation symbol. Add up all data values, divide by the total in the sample. Okay, let's do an example and then take a look at. Let's do an example. We don't need to be doing this by hand. StatCrunch does it for us, and you've probably done it by hand numerous times in your lives. Give me a second here. Okay, there we go. Use StatCrunch to find the mean, median, and mode for the traditional data set in 3_1_19. Where is it located? Stat, summary stats, columns, mean, median, and mode. It just does the math for us. How delightful is that? So we're going to go into here. Chapter 3, and I said what? 3_1_19, the first one. And this is this is just a data set of, I can't remember, I think they came up with scores for a traditional classroom versus a flipped classroom, I think is what this is. We're not concerned too much about that. We want to find the mean, median, mode of the traditional data set right here. And we'll go to stat, mean, median, and mode are summary stats. So we'll go to summary stats, and we'll go to columns because it's in a column. And there we have it. So we're going to select our column. Well, that's the traditional. We had two columns here, both traditional and flipped. We'll select traditional. And notice in our statistics, there are 11 items that are default selected. So if we go into here, you can see all the ones they've defaulted. There's the mean. There's the number of items in the sample. There's the median. Right there. Do they have the mode? I think they have mode somewhere in here. I thought they had mode in here. Mean, median, min, max. Mode! Looks like in my case I need to check it because it wasn't being checked automatically. That might be different for what you have using your laptop. Again, I'm on an iPad and it's a little different than my laptop shows it. So there's the mode. And again, if you want to unselect these things, we're just looking for mean, median, and mode. We could unselect all these things. There's our how many in the data set. So we could do that. It doesn't really matter. We're just going to read off the data. So I'll go back and check them so you can see. There we go. And then we'll compute. And you can see here, there's a traditional data set. All these were selected, but I'm only concerned about the mean, the median, and the mode. We'll talk about these other pieces in other lectures. So the mean is 7181. Let's note that. 82 actually, 7182. I'm gonna make a note over here. The median is 70.8. And the mode, there is no mode. So in the traditional data set, that's our mean, median, and mode. Let's go back and answer the question. Okay, the mean. And I went out to hundredths. We got 71.82 for the traditional data set. The median And what value separates the top 50% from the bottom 50%? 70.8. Let's remind ourselves the mean tells us that if all of those numbers were the same number, they would all be 71.82. The mode, did any of those numbers occur most often? And the answer is nope, there was no mode. No number occurred more than any other number. So we have no mode. Okay, let's kind of talk to how the mean, median, and mode look with our distributions. Okay, and see this graphically. The word resistant in statistics is a numerical summary of the data. For example, mean or median is said to be resistant if extreme observations that are very large or very small, do not affect its value substantially. So a very large or a very small data point does not affect the mean or the mean substantially. It's resistant. Okay, the median is resistant. All right, a large value, an extremely large value or an extremely small value really has next to no effect on the middle value. Okay, it doesn't change the middle much. The mean is not resistant. You know, if you take 5 test scores and if five test scores are all around, let's say 70, and then you take a 6th test score of 0, well, that's going to pull your mean down. That's going to have an effect on your average. It's not going to have an effect on your middle, because your middle is still going to stay in that 70 area. So an extremely large or extremely small number rarely has an effect on the median. It almost always has an effect on the mean. Okay, so let's take a look at how the relationship between that information and the distribution shape, which we've talked about. Okay, if we're skewed left, remember that as a reminder, that means our tail, it's not symmetrical, and our tail goes to the left. Okay, the mean turns out to be smaller than the median. Okay, and again, the mean, because the mean gets pulled to those really large values, toward those large values. The median is resistant, the mean's getting pulled. So the mean is less than the median if it's skewed left. If it's skewed right, the opposite happens. Remember, skewed right, we're talking about the tail goes off to the right. The mean is going to go with it, and it will therefore be larger than the median. Okay? Finally, if it's symmetric, and again, we know uniform, but we're going to be focused on bell-shaped, the mean and the median are roughly equal to one another, and you could kind of use either. It's these situations where the mean kind of follows the skew. You know, if your data is skewing off to the left, the mean kind of winds up following it because it is not resistant. And this similarly over here. So there you have it, mean, median, mode, and a little bit about resistance.